Okay, we're going to do a few acceleration calculations. We're going to use that mathematical definition of acceleration to figure out, essentially, the most important thing we want to figure out is the sign of our acceleration. I don't really care about the numbers. What I care about is whether you understand that acceleration is a vector quantity. It can be positive or negative. So let's figure out whether this is going to be a positive or negative acceleration. So we've got an object that's moving to the right at 2 meters per second, and then after some time, and again, we don't care about the time, could be a couple seconds, could be a couple hours, who cares? But after some time, it winds up going 5 meters per second to the right. Now, the way I like to illustrate this is by using a speedometer. You've got speedometers in your cars, right? Well, your car may have the digital speedometer. Let's pretend that we've got one of those old needle speedometers. And when your speedometer is like this, when it's flat, that's 0, right? You're not going anywhere. So that's not the case for this situation. We were going initially at 2 meters per second to the right. So notice I'm up here like this. That's when I began. And then sometime later, I wind up here, 5 meters per second. Remember, acceleration is the change in velocity divided by the change in time. So notice I went from here to here. If I wanted to calculate the change in velocity, I would say, okay, where did I wind up? How fast was I going after everything was done? I'm going 5 meters per second, minus my initial velocity, which was positive 2 meters per second. So notice my change was 3 meters per, I went from 2 to 5, right? So 5 minus 2 is 3. My swing here was a positive 3 meters per second. How long did it take? We don't really care. The important thing here is that my numerator is positive. The change in velocity is positive. The change in time is always going to be positive. Right? We can't go back in time. Time always marches forward, so your change in time is always going to be a positive quantity. So if you've got, in this case, we're trying to calculate acceleration, and if I know my numerator is positive, and by definition, my denominator has to be positive, then therefore, my acceleration has also got to be positive. Those aren't t's. Those are supposed to be plus signs. So again, my numerator is positive. My denominator is positive. We are dealing here with a positive acceleration. I don't think I mentioned with my hand speedometer here, of course it does come in handy, but I actually paid a little extra for my hand speedometer. And actually, I got a velocity meter. Now your speedometer in your car only goes one way, right? When you back up, it doesn't go down like this, but my velocity meter can do that. It can actually go below and therefore show negative velocities. Remember, this is 0. So therefore, in this situation, I've got an object that is going to the left at negative 2 meters per second. And then sometime later, again, we don't really care about the time, but sometime later it winds up going negative 5 meters per second. It's going faster to the left. And the question is, what's the sign of the acceleration? Remember, I started like this and I wound up like this. So to calculate velocity, to calculate acceleration, you want to find out if for the numerator, you need the change in velocity. So I went from negative 2 to negative 5, or in order to calculate that, I say, okay, minus 5 minus a negative 2. If you remember, minus a negative, that's a plus. So minus 5 plus 2 still gives me negative 3. I had a negative 3 swing to go from negative 2 to negative 5. So therefore, in calculating my acceleration, remember again, the important thing is the numerator, the sign of the numerator. My sign is negative in the numerator. Of course, my denominator, because it's a change in time, is going to always be positive. So a negative divided by a positive gives me negative. The sign of this acceleration is negative. Let's try this one. So now we have an object that's going to the right at positive 5 meters per second, and then sometime later, it winds up going at positive 2 meters per second. So it's still going to the right, but it's not going as fast, right? So let's do, again, use our speedometer. Remember, this is 0. So positive 5 is this. This is how we start. And then sometime later, we're still moving, right? We're still going to the right at 2 meters per second, but we're not going as fast. So the question is, how would we define our acceleration here? Is it a positive acceleration? Is it a negative acceleration? Again, the key is to take your difference in velocities. Acceleration is a change in velocity. So it's where you wind up, 2 meters per second, minus where you started, which was positive 5 meters per second. So or essentially we can look at this swing. We went from 5 to 2. What is that swing? It's a -3 swing. It's a negative change. We slowed down. So therefore, my numerator here is a negative. My denominator is always going to be positive because it's a change in time. Therefore, a negative divided by a positive gives me negative. And finally, our last permutation. Now we are going to the left at -5 meters per second. Remember, the negative there is significant. Velocities do have direction to them. So we're going at -5 meters per second, and then sometime later we wind up going -2 meters per second. So we're still going to the left, but we're not going as fast. And so the question is, what's the sign of our acceleration? Again, what's that swing there? Notice I go from -5 to -2. To calculate it, what I would do is I'd say, okay, where did I wind up? -2 minus where I started, which was -5. A -2 minus a -5 winds up being +3. Notice this is a positive change here. I go from -5 to -2. It's a positive change. So therefore, again, calculating my acceleration, I wind up with a positive change in my numerator divided by, of course, the change in time is always going to be positive. So therefore, positive divided by positive gives me a positive acceleration.